So now we'll address puberty and climacteric, which is male menopause, otherwise known as andropause. So in humans, the reproductive system remains dormant for several years after birth. At ages 10 to 12, most boys, and about 8 to 10 years in most girls, we see a surge of pituitary gonadotropins, so GnRH, and that's going to awaken the whole reproductive system, which is the onset of puberty. Now, there are various definitions of adolescence and puberty, and so we're all on the same page. We'll define adolescence as the period from the onset of gonadotropin secretion in reproductive development until the person attains full adult height. Puberty is the first few years of adolescence until the menstrual period occurs in girls, or the first ejaculation with viable sperm occurs in boys. That's typically around age 12 in girls and around age 13 in boys. So the whole event of puberty is controlled by the endocrine system. The testes have two major bursts of testosterone secretion. First of all, one during fetal development, which is where we see the sexual differentiation that we covered earlier. And then the testes become dormant, very, very, very low levels of testosterone secretion until puberty. During mid-puberty, the levels are as high as they were about 3 months of fetal development. Once we see testosterone secretion at puberty, we're going to see that reproductive function is regulated by hormone links between the hypothalamus and pituitary and the gonads. As the hypothalamus matures, it produces gonadotropin-releasing hormone, and this is the hormone that stimulates the anterior pituitary to secrete follicle-stimulating hormone and LH, or luteinizing hormone. So FSH and LH are secreted from the anterior pituitary by cells called gonadotropes. Those are cells specific to the gonadotropin hormones FSH and LH. Those are released into the blood and they make their way to the testes, and they have a variety of different effects. Follicle stimulating hormone is going to stimulate the sustentacular cells to secrete androgen binding protein. And that binds testosterone, keeping it in the seminiferous tubule so that it can stimulate spermatogenesis, thus raising the sperm count. Now, LH stimulates the interstitial cells. Sometimes it's known as interstitial cell stimulating hormone, or ICSH. But it stimulates the interstitial cells to produce testosterone. We can see this illustrated in this figure. We have the hypothalamus here and the pituitary gland here. Now, the hypothalamus secretes GnRH, and GnRH stimulates the release of LH and FSH from the anterior pituitary gland. FSH, you can see here, goes to the sustentacular cells and causes them to produce androgen binding protein. LH goes to the interstitial cells and promotes the production of testosterone. Testosterone will then feed back to the hypothalamus, and it will cause secondary sex characteristic development and development of the secondary sex organs. Only in the presence of androgen binding protein do we see testosterone having an effect on spermatogenesis. So it's important to increase the testosterone in the seminiferous tubule to have this binding protein here to hold on to it, sort of stockpile it. So pause a moment here and take some time to diagram out the relationship of the hypothalamus, pituitary, and gonads in the male, and the influence of GnRH, LH, and FSH. We'll add some more to it in a moment. So, hormones have many different effects during puberty and in adulthood, but especially in puberty. In puberty, we'll see that these hormone secretions have an effect on the enlargement of secondary sex organs, like the penis, the testes, the scrotum, and the ducts and the glands. Now, the penis will continue to grow for a couple of years after testes reach their full size. Testosterone stimulates a burst in generalized body growth, including limb elongation, muscle mass increases, and the larynx enlarges, forming the characteristic Adam's apple that we see in the male throat. Testosterone also stimulates erythropoiesis and increased basal metabolic rate, and of course an increase in appetite to support all of this. A version of testosterone also stimulates pubic hair development, scent, and adolescent sebaceous glands. And this hormone's name is dihydrotestosterone. It's a highly active form of testosterone. In fact, there are some mutations where there's no enzyme that converts testosterone into DHT, and so you don't see development of secondary sex characteristics. Testosterone is also going to stimulate sperm production and increase sex drive. In adulthood, testosterone is about sustaining the male reproductive tract, sperm production, and libido. Here we'll see another role of a hormone called inhibin. It's secreted by the sustentacular cells, and it acts to suppress FSH output from the pituitary and thus reduces sperm production without reducing LH, which allows the continued secretion of testosterone. We can see this when we go back a slide and look at this figure. Here you can see inhibin that's produced by the sustentacular cells going back to feedback and shut down the production or action of FSH so that it cannot promote production of androgen binding protein, and thus we don't see the accumulation in the testes of enough testosterone to allow development of sperm. However, we do still see a baseline level of testosterone secretion that can go out into general circulation. So take a moment now to add to your diagram and fill in the role of inhibin in the adult male in shutting down the production of FSH, so we can regulate the production of sperm. Now we'll move on to aging and sexual function. So we're all pretty familiar with the idea that women go through menopause. Well, men have a parallel event, and it's a result of a decline in testosterone secretion. Testosterone secretion peaks at about the age of 20, and after that it declines slowly. By the time a man reaches 80, there's only about 1/5 of the testosterone that he had when he was 20. This is the result of a decline in the number of interstitial cells, as well as the activity of those interstitial cells. So we see less testosterone production. We also see a decline in the number and activity of sustentacular cells, and thus we see less inhibin. And if we go back to this figure, you'll remember that inhibin and testosterone have a negative feedback effect on the production of FSH and LH, which causes a rise in FSH and LH secretion after the age of 50, and it produces some effects in males. Some men have little to no effect, and some men have a fairly dramatic effect that almost mimics female menopause, with mood changes, hot flashes, and an illusion of suffocation. Often this decline causes some erectile dysfunction or impotence, which is the inability to produce or maintain an erection that's sufficient for intercourse. About 20% of men in their 60s experience erectile dysfunction, and about 50% of those in their 80s. It's interesting to note that even though there is impotence, these men are still generally able to ejaculate. So now add that to your diagram. The influence of declining numbers and activities of interstitial and sustentacular cells, and how they might influence FSH and LH secretions. This concludes our section on puberty and the climacteric. Next, we'll take a look at the development of sperm and the production of semen.